Sure. All right. Hello. We are Group Project 5, and our project focused on redesigning ORNL's medical isotope production packaging process for safety and efficiency. Next slide. So this is our project overview. We're going to talk about the background, our process current state, problem statement, our A3, some of our improvement goals, and the expected benefits. We'll go into the causal analysis and our proposed countermeasures and the implementation plan. We'll also have our spaghetti diagrams and then our follow-up actions. So our team, I'm Allison Peacock with ORNL. I'm an isotope processing and manufacturing group lead. We have Heather Harrison, Y12 Nuclear Engineering, Molly Turner, Y12 Production Planning and Controls, Nathan Baker, Y12 Independent Assessment, and Pierce Wooten, Y12 Assembly Process Engineering. So we discussed looking at a hypothetical problem, but agreed that this would be a more interesting project if we tackled a real life problem. So we chose a challenge that we actually have in my group. The Isotope Processing and Manufacturing Division produces isotopes to meet the needs of the DOE isotope program and reduce U.S. dependency on foreign suppliers for those isotopes. ORNL has the largest portfolio for isotope production in all of DOE IP. And our mission is to deliver isotopes as promised. We produce isotopes for medical, industrial, and research applications. And then specifically in our group, we produce, package, and ship medical isotopes used for cancer therapies. These are produced under stringent FDA regulations where quality is at the forefront. So this problem really focuses on our packaging process, which is set up like an assembly line. This is performed in limited space, and it's important that the right vial is placed into the correct shielded lead pig so that we aren't shipping incorrect amounts to customers. We identified a significant amount of waste in motion when defining our problem, and we'll show that with our spaghetti diagrams later on. So essentially, the operator bags product vials out of the glove box. Those are transferred to the fume hood, where an operator is stationed to decon those vials. They're checked by an RCT. If they're clean, they're labeled, and then they're passed on to our quality control check. The operator then passes those on to another operator, which loads the vial into a shielded lead pig. It's closed up and taped. The RCT smears the pig and tags it for shipping, and then we repeat that process for all the remaining vials of shipments going out that same day.
All right, so moving on to the problem statement. This is just a way that we can kind of boil down the current process steps and some improvements that we would like to make or based on what the issues that we've been experiencing are. So problem statement that we came up with for this project is the current packaging process for medical isotopes involves several steps. Bagging out product files, decontamination, labeling, quality control, and final packaging. Operators often run into each other during these processes, leading to wasted motion and increased risk of safety issues, radiological contamination, or packaging errors. You can do next slide. So one of the ways that we kept all the information in order was an A3 problem-solving format sheet. So one of the cool things about A3 is that no matter what type of project you're working on, it's a way that you can boil all of the information down, all the high-level details of the project into one piece of paper that can be applicable to both the lowest and the highest ranking member of the team and anyone in between. So, it's going to have everything from, your problem description and your goals and benefits all the way down to your causal analysis and implementation plan and things of that nature. So, we found a format that we liked, one that kind of made sense and flowed well within our process. And, there's a million ways that you can write these, but they're all extremely helpful, especially if there's a group with a lot of high turnover. In my experience, it's been very helpful to have A3 sheets because on your way out the door, you can hand one to the new team member, and it's a way for them to kind of catch up to speed really quickly on something going on. So next slide, please. The improvement goals is something that is listed in the A3, but we wanted to explain it a little bit more in detail. So there's 5 goals that we were expecting for improving this process, the description as we had below. So those 5 are to streamline the packaging process to reduce congestion, and we'll get into this a little bit in a second, but we also want to minimize wasted motion and improve safety and enhance the overall efficiency of the packaging workflow by reducing the cycle time. So we also want to improve the quality by eliminating the risk of any vial mix-ups and standardized work for sustainable operations. So all of these will be ways that we can take the current process and improve it in some slight way that will pay dividends in the long run. These aren't really mechanical changes, which is kind of the thing that I had to get over, just coming from purely mechanical engineering background. But these are things that aren't exactly like speeding up the machining themselves, but the processing in between. So that's been really helpful. Next slide, please. So expected benefits we anticipate from this project will be better flow throughout the work area, as well as improved efficiency by way of reducing the cycle time for the project, as well as enhanced safety, which will be from minimalized collision risks, and also better quality control due to both the consistency in the process as well as just going back to that collision risk. If you're not going to have any collisions, then you're not going to have any quality concern with the collisions themselves because they won't exist. And then also scalability as well. So it'll be easier to adapt for volume change or demand in the future. And also be the foundation for future improvements and some PTCA style upgrades. So next slide.
So to really get to the root of what our issue was, we decided to do a 5 why analysis, which essentially started out with the question of, okay, why are the operators running into each other, which leading through all of the questions led us to there was a lack of updated processes and standardization. So essentially what this boiled down to was the fact that the lab was originally set up for R&D work, but then with the growing need for medical isotopes for cancer treatments, it was identified that production isotopes and R&D isotopes needed to go into separate labs. So this one itself was, again, designed for an R&D lab, but now it's a production lab, so the layout of it just wasn't efficient for what it's being used for. Next slide. So these are our proposed countermeasures, starting out with evaluating the current process, which includes going to Gemba to figure out what exactly is happening on the floor, reconfiguring the workspace layout by implementing 5S techniques, as well as implementing some visual management tools such as flowchart development or even displaying some SOPs. So creating standardized work, introducing a pull system using Kanbans, and implementing enhanced operator training. Next slide.
So thank you. And as part of the project, we mapped out how the layout is going initially with the spaghetti diagram. And I think you can see pretty clearly there's just a lot of people all over. There's a lot of spaghetti. There's certainly level loading issues. Most of the work is front loaded in glove boxes at stations 1, 2, and 3. So one of the things we tried to look at was doing a different layout. And you can see we've tried to organize it where we're keeping most of the operators on one side and the other ones on the other side. There's still a pretty big challenge with the front loading due to most of the work being in the glove box. And then also being radiological, there's some challenges of dosage levels. So there's going to be there's going to be some cross training to let some people work one station for part of the day and then switch around. But we do think there's a pretty good head start here to release this to the operators at Gemba. So as far as the next steps in this process and moving it forward, we kind of think with the spaghetti diagrams, we've given the operators some decent ideas, but obviously they're the experts. So we really want to get their feedback and see what direction they want to go. Once we get some kind of ideas there, push for some resources for a new layout, implement the changes, then start setting up some sustainability things like the visual Kanban, the SOPs, and finally benchmarking what our efficiencies have been.
So we've talked about our project and we've analyzed the process and what our recommendation would be. Now we're going to talk about path forward actions external to our project. So the OR&L Isotope Directorate includes 500 experts, and this is a world-renowned isotope producer for medicine research and industry. And so it's continuing to expand and grow in this field. And so there's some actions that we know need to come for generations and expansion for this field. So what needs to happen external to this project and for Allison's organization is this needs to be proposed in terms of the improvements that are being recommended for the respective OR&L management team. If agreed to, you need to execute the proposed implementation plan, perform additional data analysis and assess the effectiveness of the proposed changes, and then continue ongoing data feedback to ensure that the improvements are as recommended, and then assess the cycle time to evaluate sustainability for the long term. Next slide. So in summary, we've talked about some significant improvements that we are projecting from this project. So we definitely propose that we're going to see significant reduced cycle times, reduced wasted motion, potential quality concerns will be reduced, implementation of standard work. And while we don't necessarily have exact quantitative impact, we do expect that our initial analysis of this proposal will yield some performance enhancements. Next slide. Any questions?